Welcome to the DIY Honda Garage channel. The diagnostic trouble code DTC P0452 refers to a low voltage issue in the fuel tank pressure FTP sensor circuit. This occurs in the Honda Civic models from 2006 to 2011. The FTP sensor plays a vital role in monitoring the pressure inside the fuel tank and ensuring the evaporative emissions control system operates properly. Its location is typically near the fuel tank, making it essential for fuel system diagnostics. When this error code shows up, it indicates that the sensor is not providing the correct voltage signals, potentially leading to increased emissions or even engine performance issues. Proper troubleshooting and resolution of this error are crucial to maintain vehicle efficiency and compliance with emission standards. The primary component affected by DTC P0452 is the fuel tank pressure FTP sensor. This sensor is primarily located near the fuel tank and is responsible for monitoring the pressure within the fuel tank. It sends real-time voltage signals to the engine control module, ECM, to help in monitoring and controlling evaporative emissions. A malfunctioning FTP sensor can lead to various issues such as incorrect fuel pressure readings, potential fuel leaks, and increased tailpipe emissions. The sensor typically operates within a voltage range that allows the ECM to evaluate the fuel system's performance. Thus, understanding its role and location is crucial for accurate diagnostics. There are several possible causes for DTC P0452 to trigger. One likely cause is low voltage flowing through the FTP sensor circuit, meaning that it is not receiving the necessary voltage level to function properly. Another possibility is that the FTP sensor itself could be faulty or damaged, requiring replacement. Additionally, wiring issues, such as frayed or broken wires connecting the FTP sensor to the ECM, could be contributing to the voltage drop. Lastly, problems with the ECM itself may cause incorrect readings and signal issues, leading to the activation of the DTC. Each potential cause needs to be examined thoroughly for effective troubleshooting. Some common symptoms associated with DTC P0452 include the activation of the check engine light, CEL, alerting the driver to a potential issue. Additionally, there may be noticeable fuel efficiency problems, meaning the vehicle may consume more fuel than normal, which could impact overall driving costs. Poor engine performance can also arise as a result of imprecise pressure readings, potentially leading to rough idling or a decrease in acceleration. Moreover, if not addressed, this DTC can result in failing an emissions test, which may prevent the vehicle from being legally driven on the roads. Recognizing these symptoms early can lead to prompt repairs, preventing further complications. The first step in troubleshooting DTC P0452 starts with turning the ignition switch to the on position, which activates the vehicle's electrical systems while ensuring that the engine control module, ECM, is powered up for diagnostics. This allows for the retrieval of important data, including any stored freeze frame data that captures the vehicle's operating condition at the time the fault was recorded. It's essential to record any onboard snapshots as well, as this information can assist in assessing the vehicle's performance prior to the occurrence of the error. As a technician, it's crucial to review the general troubleshooting information before moving on to the next steps of diagnostics. The second step involves clearing the DTC using the Honda Diagnostics System, HDS. This reset is crucial because it clears any previous error codes, allowing for a fresh start in diagnosing the fuel pressure sensor circuit. Clearing the code also enables you to monitor real-time data and conditions without interference from old fault codes. Before testing begins, this helps ensure that any subsequent readings reflect the vehicle's current status rather than historical data. Once cleared, the technician can proceed seamlessly to subsequent checks, knowing that the system has been reset and is free from old faults. Next, Step 3 requires turning the ignition switch to the lock 0 position. This step ensures all electrical systems are powered down, safe for the next processes. After this, remove the fuel fill cap. This action is necessary to relieve pressure within the fuel tank, making further checks safer and more effective. Removing the cap not only assists in gaining access to the FTP sensor, but also helps in resetting its conditions, allowing for more accurate data readings during monitoring. This step is part of a safe approach to troubleshooting that prevents unnecessary risks and accidents. In the fourth step, turn the ignition switch back to on. 2. To activate systems again, enabling the collection of essential sensor data. At this stage, the technician should check the FTP sensor readings using the HDS to see if the values are about -7.3 kilopascals, -2.16 inch-rig, -55 millimeters inch-rig, or 0.3 volts or less. These specific values are important benchmarks that indicate whether the fuel tank pressure sensor is operating correctly. If the reading meets these specifications, it implies that the sensor circuit may be functioning well. Conversely, if the readings are incorrect, further investigations into the wiring and connectivity would be necessary. Step 5 involves reinstalling the fuel fill cap after confirming the FTP sensor readings. This step allows you to prepare the vehicle for the next phase where the engine will be started. Once the cap is properly secured, start the engine and allow it to idle so that all systems can stabilize. During this idle period, monitor the onboard diagnostic (OBD) status for DTC P0452 via the HDS. The purpose of this step is to observe if the previously triggered error code reappears, providing insight into whether the FTP sensor circuitry is consistently underperforming. Any further anomalous statuses should be noted and acted upon based on HDS readings. During the sixth troubleshooting step, the technician must closely monitor the OBD status on the HDS for indications regarding DTC P0452. If the screen displays failed, this directly implies that the issue persists, warranting further investigation. If it indicates passed, it suggests that the system may have resolved its previous fault, at least temporarily. However, if it shows intermittent failure, it is crucial to check for poor connections or loose terminals at both the FTP sensor and the engine control module, ECM. Should the status display not completed, the engine should be kept idling until a definitive result is generated, indicating whether the fault remains active. In Step 7, turn the ignition switch back to lock 0 to ensure all systems are completely powered down before proceeding with the diagnostics. Next, disconnect the 3P connector from the FTP sensor carefully, making sure not to damage any terminals or wiring in the process. This disconnection is essential to further investigate the sensor's functionality and conduct measurements without interference from other components. Lastly, once the sensor is disconnected, you are set to proceed to the upcoming steps that will help in diagnosing whether the sensor itself is the root cause of the issue or if the problem lies deeper in the vehicle's electronic systems. For Step 8, the technician will turn the ignition switch back to on 2, allowing the systems to energize once more. This action enables the possibility of gathering FTP sensor data without the sensor's influence or bias in the readings. Using the HDS, re-examine the FTP sensor data in the data list to check if the reading is again at approximately -7.3 kilopascals, -2.16 in inch weight, -55 millimeters mercury, or 0.3 volts or less. This check will help to assert whether the absence of the sensor contributes to a significant change in reading. Should these values appear again as previously noted, further steps must be taken to investigate the integrity of the wiring and connections leading to the ECM. In Step 9, it's time to measure the voltage at the FTP sensor's 3P connector. Use a multimeter to check the voltage between FTP sensor 3P connector terminal number 1 and body ground, focusing particularly on the red VCC6 wire. It is essential to ensure that the voltage reading is approximately 5 volts, as this indicates proper function and communication between the FTP sensor and the ECM. If this reading meets such specifications, it suggests that the sensor might still be operative. However, if the voltage is inadequate, this could potentially reveal a deeper issue, either with the sensor itself or the wiring harness leading to it. This step is crucial to narrow down the malfunctioning component. Finally, in Step 10, switch the ignition back to lock 0, ensuring safety before proceeding with the intricate diagnostic checks. Then, jump the short circuit SCS line using the HDS, which will allow easier access to perform further diagnostics on the electrical systems involved. This step facilitates identifying any short circuit issues that might not be readily apparent. Following the jump, disconnect the ECM connector A, 44P, as this disconnection can enable you to examine potential internal failures in the ECM or verify wiring integrity without erroneous readings caused by the connected module. These steps will ensure that you cover all bases while troubleshooting DTC P0452. After completing all troubleshooting steps for DTC P0452, it's essential to conduct a final repair verification. This verification involves rechecking all relevant systems to confirm that they are operating correctly and that any repairs made have resolved the identified issues. Confirm that the diagnostic trouble code has been successfully cleared using the HDS, ensuring the vehicle is not currently exhibiting any faults. Following this, performing a road test is advisable to ensure the vehicle functions appropriately under actual driving conditions. This test will help to reaffirm any fixes are sustainable and that the system operates within its specifications, providing peace of mind for the technician and vehicle owner alike. Preventive maintenance plays a crucial role in averting issues like DTC P0452 from arising in the first place. Regular visual inspections of the fuel system and all associated components, including wiring harnesses and connectors, should be a standard part of any service routine. Checking for signs of wear, fraying, or corrosion can identify potential problems before they escalate. Additionally, monitoring the overall health of the fuel system can help maintain efficiency and performance. Keeping all connections clean and securely attached reduces the likelihood of intermittent faults that often lead to such DTCs. Regular upkeep will save both time and money in the long run. In conclusion, understanding the role of the fuel tank pressure FTP sensor is vital for effective diagnosis and repair related to DTC P0452. This DTC indicates low voltage in the FTP sensor circuit, making it essential to ensure accurate readings for proper engine management and emissions control. The troubleshooting steps outlined provide a clear sequence to methodically address the issue, increasing the chances of successful resolution. Proper preventive maintenance can further minimize the risks of encountering similar diagnostic codes in the future. By focusing on the FTP sensor and ensuring its reliable performance, technicians can maintain vehicle efficiency and compliance with emission standards. Please like and subscribe to the channel. See you next time.